So I'm Nicolas Frankel. I've been a developer for a long time as developer architect, solution architect. I'm always a consultant working for like different companies in projects, mainly Java, Spring, Java EE earlier. Since a bit more than 1 year, I'm a developer advocate, and I work for a company called Hazelcost. Who knows about Hazelcost? Yeah, I love it. Great. So you probably know about IMDG, the caching solution, the in-memory data grid solution. Now we have another offering, and basically we have Jet. So it's a data processing product that is built on top on IMDG. So if you have like needs for like very fast data streaming, just please have a look at it. This is our agenda for today. So I will start by introducing the context and try to debunk some myth first. Then I will describe you what can happen in microservices architecture, a possible solution, and how it can be implemented. And if we have time, we can have a demo. Who here is already doing microservices? Come on, don't be shy. So half the room. Okay. I mean, who doesn't want to do microservices? You need to do microservices because Google, Spotify, Netflix are doing microservices. So if you want to be like, to have your next employer being a cool company, you need to do microservices. And this is the definition of microservices that is found of Martin Swoloblicki, that I didn't invent anything. This is what it tells microservices are. So basically everybody like componentizes its services, smart endpoints done by blah, blah, blah. Everything is fine until the last items. Does it work? Yes. So in general, this is a bit harder, organized around business capabilities. What about logging microservices? It's not really business capability. And product, not projects. Basically, a project has a start date and an end date. A product has a start date and goes on like that. So now, among those of you who are doing microservices, how many of you have products? No end dates, no projects. Wait, that's good. That's pretty good. That's one of the best sample I've had so far. But of course, there are less of you than before. Microservices. Everybody, what you see on the internet, in conferences, let's not say everybody, but a lot of people are approaching it from a technical point of view. Hey, let's break down this like big monolith in chunks and blah, blah, blah. But the problem is that microservices, it's an organizational solution to an organizational problem. And the only problem that microservices solve is there are too many developers. Because if you have many developers working on the same code base, then at some point your feature branches, when you need to merge at the end of a sprint, it's going to be a mess. And that's the problem that microservices solve, this problem. Only this problem. So if you try to approach microservices from a technical point of view, you will fail. Because it's a problem for the organization. Do you know Conway's law? If you are doing microservices, you know Conway's law. And basically, Conway's law tells you that your like technical architecture will reflect your organization. And the proponents of microservices, they're telling you, oh, that's easy. You just change your organization, you create those two pizzas team, and then you will have microservices. And it makes sense. By the way, on the picture, the important guy is not me, is the other guy, is Conway. So he's the one who created, like, who wrote down this law. It's super cool to have a law to your name. Actually, his Twitter handle is Conway's law. So this is an organization that does microservices. You handpick the people who are necessary to do the job. They are autonomous, so you pick developers, UX designers, product manager, whoever is necessary. They are autonomous. They don't need anybody to do their job. And this is probably how your organization works right now. Silos everywhere. You have a team of developers, and you have a team of product managers, UX designers, testers, whatever. And who sits at the top of each silo? Sorry? Managers. Who here is a manager? Good. So I can say not so good thing about managers. And the problem is, if you want to go from there to there, what do you do with the managers? Where do the managers fit into this matrix? The biggest problem of microservices is basically the people who can help you going from there to there are the one who will be rendered obsolete. And of course, that's a very bad idea to say, oh, we have a very bad architecture right now. It's a monolith. It's very badly written. So let's write microservices, because if you rewrite everything in microservices, everything will be so much better. Also very wrong reason. So in my talk, I will try very hard to avoid the term microservices, which is, like, in my opinion, super loaded and not used in the right context, and just use web service, because I assume everybody is using web services today. So we are doing web services, but in a context where Murphy's law applies. So basically, whatever can go wrong will go wrong. And you might know or remember about this UML stuff. I've been an architect. I know how to draw UML diagrams. So who can tell me what that is? Yes? Okay, so the gentleman say it's calling a method from another object. Who agrees with him? Nobody agrees with you. I'm sorry. I agree with you. So you are not alone. Another option? They are all too shy.
So, like sequence,
yeah, it's a sequence diagram, but what sequence does it describe? Yes, again?
I think basically it might be a bit wrong diagram, because if you do a synchronous call, then probably you have to write another rectangle there. If you want to write a synchronous call, then probably you need to use another arrow.
So the diagram for the recording, the diagram is criticizing my way to draw UML diagrams. So, now the problem with this diagram is it can be, as you mentioned, it can be a method call, or it can be an API call, REST call, SOAP call, anything. Yeah, message sending, whatever. And architects are very good at that kind of stuff, and then they leave up to the developers to do the details. It's an implementation detail. Well, one of the implementation detail is distributed computing. And if you go into distributed systems, a lot of things can go wrong, as per Murphy's law. Like, if you call a method, it will either succeed or fail. As soon as the network is involved, there is a third option. It doesn't succeed, it doesn't fail, You don't know what happens. You've got no response. So yeah, the problem is the network is not reliable. You have no clue what will happen. This actually should be printed out and like displayed in every office. So this is a sample web service architecture. I have two clients, one front web service and one backend web service. So if everything works right, my client sends a request to the front that's forwarded to the back to handle the stuff, and everything works fine. That's the nominal case. That's what we want. But as I mentioned, sometimes for different reasons, nothing will happen. So B might be down, or the network might be down. There might be like a network partitioning for some time. And so the requests, they will pile up on the front web service. So what's the next step? What? Sorry? F is down, yeah. And that's the problem with those like web services architecture, is that a very located fault in very like on the edge can propagate all over your architecture and destroy your whole system in no time. So you want to protect against that. And in your home, you have like this electricity issue, so you want to protect against like surges, and you have circuit breaker. So when there is a peak of electricity, you just melt the little copper thread, and then there is no electricity anymore, but at least your house is not on fire, which is a good idea. So the circuit breaker in microservices or web services is the same. As soon as you've got repeated failures, you will just shut off the damn thing and fail fast. And that's exactly how we can model that. So at the beginning, everything is fine, and we make the calls. Sometimes there might be a single failure, but that's fine, because single means just nothing bad is happening. And then afterwards, if it fails repeatedly, then we reach a threshold. So we open the circuit breaker, and at this point, we fail fast. Every time we say, oh, this is down, we fail fast. But the problem, if we stop there, then, I mean, it means your system will degrade over time and nothing good will happen. So we need a self-healing way of dealing with this. So after some point, we will try to make calls again, just to try. Oh, perhaps it's back. The network is back again. The service has been restarted. We don't know. We just try. If we succeed, then we close the circuit breaker and business as usual. If we fail again, then we get back to the open, and we might wait until more time elapses to try again. Make sense? But there are a lot of configuration options for that. For example, how many times do we need to fail before we open the circuit? How long should we wait before we try to close the circuit again? How many times do we need to succeed again to close the circuit again? There are a lot of configuration options. But what is the really very important option that we didn't talk about? The most important configuration option. Sorry? It's important, but I mentioned it here. So there is the most important option that I didn't mention. Sorry? Yeah, what to do? What's the fallback? That's the most important stuff. What do we do when we fail, when we have timeout? What should we do? So I've been working in e-commerce at some point of my career, and I like to use the e-commerce ecosystem because I think everybody can understand it. So I have like this e-commerce shop, and it's a bunch of web services. I have 4 web services that I want to highlight. The one is the recommendation web service. Like You are on Amazon, you put some stuff in your cart, and Amazon will tell you, hey, people who bought this also bought that, so perhaps you want more. Like it's called upselling. You've got the pricing web service. You've got the payment web service. And of course, you've got the logging web service because everybody wants to have logs. In the case of logging, nobody cares if it fails, to be honest. It can be asynchronous. You just fire and forget the stuff. As long as the people, they can still order, that's fine. Of course, your ops team is not going to be super happy, but fallback is nothing. You don't need any fallback. It's fine. Now, recommendation engine is a bit harder. What happens if the recommendation engine is down? There are a couple of solutions. The first solution would be no fallback. We don't try to upsell anything. It's just fine as it is. And because the people, they can still order, again, for the business, that's fine. They might not sell as much as they wanted, but they might sell enough, which is good. You might hard code some like best sellers ever, or you can put them in a dedicated database on your client web service. So they can be updated every now and then. You can cache them. So what would be the best solution according to you? Don't display them. Yeah. So no money, it's fine. Okay. Yeah, it's an option. It's an option. Other options? What would be the best options? Yes? Fine. Call another service. Yeah, it's a choice, yes. So you create another fallback service, and if the first service doesn't answer, you'd call another one that is more reliable. And I told you I was a consultant, so the right answer is it depends. The answer is always it depends, because all of those are options, and basically you are the tech guy. It's up to the business to decide. So you as a tech people, you should just say, this is the option, it costs that much, this is what it does, and you let the business decide. Pricing. Pricing is an interesting problem because many people who never worked in e-commerce, they think that a price is fixed. A price is not fixed. A price depends on a lot of parameters. Might depend on your own profile, it might depend on the time of the day, might depend whether the business wants to push the selling of a product. If the product is, there are too many products of this kind in stock, then they will try to sell it more. So there are many, many different parameters. So pricing is basically a web service. Now imagine the pricing web service doesn't work. We cannot just say, oh, there is no price, everything is fine, just like in the recommendation engine. So what should we do? Yes? Tweet the recommendation. No, the answer is it depends. Actually, you need the price. You need the price. So one possible option would be to cache the price from the previous call, previous working call, because it's better to sell at an outdated price than no sell at all. Always remember the rule of e-commerce is to sell at whatever the cost. So that could be an option. We could have another more reliable and perhaps less frequently updated web service available. Again, it depends. There are many options. A payment. Well, it's hard to cache the payment, right? Again, there are some couple of options if we think about it. Perhaps you would say, hey, we are not accepting card payment at the time, but we will send you the invoice. And then you need to pay afterwards. Depending on the country, it might work. It works very well in Switzerland like that. In France, it would never work. I mean, if you receive the product, you don't pay. Why? You already have the product. Or perhaps you can accept the order, and just afterwards, when the service is back online, you send an email to the customer saying, hey, now to trigger the delivery, you should pay. There are a couple of options. And basically, from what I just told you, there are two main strategies. The first strategy is to fail fast, provide no fallback, because we don't need it. That works very well with service meshes. It's black box. We don't care what happens inside. We just fail fast. That's fine. We don't need anything anyway. The other is we actually need to understand the business process to provide the right fallback. In that case, it's a white box, and it needs to be like developed from the inside. In that case, you need a library to do that, because only a library understands your business logic. So who here is using any kind of Kubernetes platform? Okay, a lot of people already, like half the room, 40%. So Kubernetes is hype, everybody is using Kubernetes. Again, if you're not using Kubernetes, then your resume won't be as good, whatever. I believe that a lot of people who are using Kubernetes are, again, using it for the wrong reason. Anyway, it's still very popular. And containerization is here to stay, whatever happens. And this like service mesh is built on top of Kubernetes or similar platforms, and basically it removes all the library, all the previous libraries that you relied before on to provide it in a transversal way. So for example, like service, how it's called again, service discovery. Service discovery, before you had a library to do that. If you use Spring Boot, for example, you could use like some libraries. And now you delegate it to the service mesh. Encryption, just as well. So you try to remove a lot of stuff, put it in a like common product, which is good. And Istio right now seems to be the most well-known service mesh. It's based on the Envoy proxy, and it leverages Kubernetes. What I really like with Istio is that it leverages the sidecut pattern. So basically, when you schedule a pod on Kubernetes, it will hijack, it will listen to what happens, and basically it will schedule a pod next to it so that basically they will be together. So you don't need to explicitly every time deploy this Envoy proxy. You just say, hey, I want to deploy my own container, and then it will schedule Istio next to it, well, Envoy. And every time you deploy something, as I mentioned, so you deploy another one, and it will just hijack any network communication. So whether it's outbound or inbound, Envoy, the Envoy proxy, will be there and hijack every network communication. So if you want to do circuit breaking, then you just say, hey, who loves YAML here? Really? Really? Okay. YAML lovers, that's fine. That's cool. So you write this YAML configuration file, and basically you tell it, and that's one of the configuration options that I mentioned, how many errors I need to have to start opening the circuit breaker, what's the sliding window, like here, 10 seconds, how long should it stay open? And because we are like, we know the whole architecture, we can basically say that it's better to have like a few failing pods than no pods at all, so we can still keep some of them just in case. So you can say, hey, I want to still have like 20% of the pods, just like hoping they won't fail. But the problem of Istio, as I mentioned, there is no fallback. If you fail fast, you will return a 500, and it's up to the client to decide what it will do, but basically it's very hard to provide anything. Before I let people choose whether they wanted me to talk about like Hystrix or Resilience4J, because there was a choice at some point. But last time, the people wanted me to talk about Hystrix, which has been like end of life since a couple of times, so I just will go directly to Resilience4J. I'm sorry for that, there is no choice. Говно случается иногда. So Resilience4J, as I mentioned, Hystrix has been end of life. So the Hystrix was developed by Netflix, but basically they told, hey, we won't make any new releases. We'll be doing bug fixes. Please use Resilience4J. Resilience4J is not backed by any company. It's just like a very individual efforts. It works quite well. The thing is, it's based on Java 8 and functional programming. There are few features. Among them is the circuit breaker, and there is one jar for each feature. So if you want to use multiple features, you need to import multiple jars. Each feature is designed as a function, and basically you use like functional programming to have function composition. It is based also on the library previously called JavaSlang, also known today as Vover. Are there any Vover user beside Yegor? Yeah, beside Yegor. A few, not that many. Who is a functional programmer here? Not that many. Okay, I thought there would be more. Okay, that's fine. And yeah, as for me, when I use Resilience4J, it's quite hard because I've been taught object-oriented programming when I was younger. So if you also have this kind of object-oriented programmer background, then you need to wrap your head around and view your code in a completely different way. And of course, because it's a library, because you are seeing the world from one single pod, then basically you don't see the big picture. You don't know about the architecture. You don't know the supplier of your request. Still have a bit of time for a demo. So here I have two services. Shop, and I didn't open the right one. Now it's shop and pricing. So it's very easy. The shop will call the pricing for an object. So it's a Spring Boot application written in Kotlin. I hope you can read it. And this one is a reactive application. And basically, I'm just saying, hey, when I receive a GET request, like quote / the ID of the product, I will call the quote method. Quote method just tries to compute the quote of the ID, and the compute quote is basically I take the string of the ID, I take the hash, and I try to come up with a price. So it's not completely random, it's just a bit jittering around it. And more importantly, I apply network simulation. And basically what network simulation does is after a number of grace counts, I will fail my service explicitly. So every 4 times out of 5, I will sleep, completely sleep. So basically there will be a timeout at some point. And the grace count is 10, and I will sleep for 5 minutes. 5 seconds, which is a long time. On the other side, I have this client, and this client is not reactive, but basically it will use the REST template to do the requests for the code for an object. And if everything is fine, then it will cache the result. Just as I mentioned above, previously, basically I will just use this fallback. And here you can see that I'm using function composition. So basically the first thing is a completable future async call, which is basically just a supplier. So you might know Java 8 supplier. I get objects. And then I decorate this supplier with a time limiter, meaning that after a limited time, I will just fail. And when it fails, I decorate it with a circuit breaker. And then you need to wrap your head around that, especially if you're not into functional programming. There is a fold. So the first is the result that I will provide if it didn't work, if I failed. And this is the result that I will provide if it worked. So in the result, I tell it where it comes from, whether the result comes from the cache or from the real service. And now what I will do, I will just go on. It's called again circuit breaker, so it's not this one. And I have a very stupid bash script that will repeatedly calls the endpoint repeatedly. So at some point, I will reach the grace count, and I will start failing. I will start the shop application, and I will start the pricing application. So this is pretty quick because it's reactive. This one might be a bit longer. Failed to start. I love it. So somewhere I have a Tomcat that is running. Yes, this one. Should never try working when you are just before doing a presentation. Okay. There is a stack trace, but it should work. It's probably some previous session that was. So here everything works. Like the first 10 calls, everybody is happy. Like my web service architecture behaves as expected. And then now you see that there is a timeout. It takes a long time, but the circuit breaker is not open yet. And now I fail fast, and now the circuit breaker is open, and so I get the result like very, very fast. And you might wonder why. Like though I take the stuff from the cache, I still might have different numbers sometimes, because even if the call is timed out, at some point I still might receive the results still, so the cache gets updated anyway. And now normally, like every now and then you should see like, hey, it worked. So this is the demo. Okay, thanks for your attention. You can read my blog where I publish daily posts, Java, Kotlin, Spring Boot, Kubernetes, whatever. You can follow me on Twitter, and more importantly, you can get the demo and play with it at this GitHub repo.